welcome to our channel. In this session, we will discuss the concept of BFS, Breadth First Search in Artificial Intelligence. So, wherever you are going, BFS is an uninformed search strategy, means it does not follow any heuristics. It blindly follows blind search. That means it explores all the nodes at the current level and then move to the next level. In the next level, explore all the nodes. That means BFS is a level by level exploration. That means expand all the nodes at depth D before expanding the nodes at depth D plus 1. You got the point? First at level D, it explore all the nodes and then only it moves to the next level. Now, BFS uses a queue data structure. BFS uses queue data structure. And one more important thing is coming to completeness. Coming to completeness. BFS always finds a solution. In DFS, there is no guarantee to find the solution, but in BFS, he always finds the solution. This is the algorithm. Observe, this algorithm is almost similar to DFS that we discussed in the last session. Again, I am repeating what happened in the initialization. I am maintaining two lists, open and closed. Here, what is mean by this one? This is called a node pair. What is node pair? Node pair means it consists of two things. One is the current node and then the parent node. Initially, start is the root node. For that, there is no parent, that is nil. Now, while open is not empty, we are doing the process. What is the process? First to retrieve the head node. That is in the node pairs, retrieve the first node pair from this node pair. Node pair consists of two elements. From this node pair, extract the exact value. Now you got it? This is the node pair. Within this node pair, we are getting the value node. That means the current node that we are going to perform. If that node is the goal node, if that node is the goal, then simply you are reconstructing the path. Why we are reconstructing the path? You know the procedure. Reconstructing the path. Why you are always writing the path in the reverse direction. To get the original answer, I am changing the direction. After that, suppose if this is not the goal node, what you need to do? What you need to do? Simply that node is placed into the closed one and generate all the children's. While generating, remove the nodes that are already visited to avoid infinite loop and then make the new pair and append the new pair at the tail. Append the new pair at the tail. The same process is repeated until the open list is empty. Until the open list is empty. Okay. Now we will discuss this BFS in the simple terms like this one. This is the time complexity. B is, what is the B value and what is the D value? B is the branching factors. That means the maximum number of successors of any node. D is the depth of the shallowest goal node. This is the branching. And based on this, the time space complexity is also there. Anyway, I said BFS is complete means there is a possibility of solution exist. Now, we will discuss the BFS algorithm with one example. BFS algorithm with one example. Initially, we are maintaining two lists. One is open and another one is closed. What initially consists of? S comma nil. Initially, it consists of only one starting and closed is empty. So, my searching process start at S and expand this node pair and immediately check. While expanding, check if S is the goal node, answer is completed. S is not the goal node, then what you are doing? Expand. So in the node pair format, what is the node pair format? Current node followed by their parent. A is the node, their parent is S. similarly BS, and similarly CS. Now, whatever the node pair that is visited, that is placed in the closed one. Okay. This is after expanding S, and by placing this one, remove the S from the open and place it into the close. In the next step, expand A. Here, if you observe carefully, here BFS follows Q data structure, and always remember, so, sir, first to C is considered, no problem. If you are writing in the reverse order, CS, BS, AS, CS is considered. Here, order is not at all important. Why? All are neighbors. You can pick the nodes in any order. That is not a problem. Now, while expanding A, now B comma S, C comma S, always the inserted node is at the end. What are the child to A, E? How do you represent the child E and the parent A? This is the representation of node pair, and A comma S is added to closed AS. Already S nil is available. In the next iteration, expand B. The next iteration, expand B. What are the unvisited neighbor? So for B, S is there, A is there, and D is there. Okay. And S comma A are already visited. Now only possible is D. Now CS EA plus DB. This is the child of B. And here B comma S is added. BS, AS, S nil. This is added to the closed list. This is added to the closed list. You got the point? Now B expand C. In the order only. Expand C. So what are the child to C? D, S, G. D and S are already completed. EA, DB, and then GC. C is the parent. Observe the representation of node pair. Here CS, BS, AS, S nil. Now, in the next iteration, expand EA. Sorry, expand E. What are the neighbors of E? Neighbors of E are D comma G. For example, if you want, you can write DB and GC, and G is, up to now, G is not visited. Yes or no? If you are placed in the open, means not at all visited. If you are exploring, then only the nodes are visited. So you can write GE, or else if you want, you can ignore this one also and simply modify the algorithm like this. How? If it is element in the open, that is also removed. So here I written this one also. That is the reason what I am doing. Simply I am removing this one. Why? G is already present in open also. G is present in open also. Now expand DB. While expanding DB, what are the neighbors? C, E, G, B. All are completed. Simply write D comma B, and all are here. And what is here? GC only. Now G. So in this node pair, G is the goal node. If G is the goal node in the sense, if G is the goal node in the sense, my operation is completed. Now observe the path. G. What is the parent of G? What is the parent of G? C. Now observe in this path. What is the parent of C? The parent of C is S. That is reconstructing the path. Now, what is the final path? S tends to C, C tends to G. Here you are identifying the shortest path. You are identifying the shortest path. You got the point? Got the point? In the DFS also you are getting the answer. But in the DFS, there is no guarantee of shortest path. You observe, remember, in the DFS, you are getting the path like this. S tends to A tends to E tends to G. This is the path you are getting in DFS. But here with only 3 nodes only, I am reaching this one. This is BFS to find out the shortest path. Okay. Thank you.